We're going to be talking about perceived performance today and some of the recent work that we've been doing at Mozilla. I am Heather. I'm based in Toronto, and I'm a user researcher on the Firefox team. This is not Toronto. I realized after the fact this is like me perpetuating stereotypes about Canada with that photo, but anyways.
Hi, I'm Gemma, and I'm also a Firefox researcher. I'm based in Seattle, and this is not Seattle either. This is actually in Banff, so also a Canadian photo. Yeah, so are we getting feedback, or is that just me? Okay, maybe.
Okay. I think when you switch. Oh.
Let's maybe just put that over there, just in case it's not. Okay, so as user researchers, we often evaluate products by focusing on how they fit into users' lives, whether they provide value, and if they are usable for people with a range of abilities. User perceived performance matters because it can have a significant impact on a user's overall experience with a product. Assessing user perceived performance helps inform decisions not only for engineering, but also for our product and UX teams. So Mozilla is fairly old in terms of most modern tech companies. While Firefox 1.0 was released in 2004, the Mozilla project actually started several years earlier. And our company history page includes the following explanation of our origin, and it's unsurprisingly pretty engineering focused. It reads, the Mozilla project was created in 1998 with the release of the Netscape browser suite source code. It was intended to harness the creative power of thousands of programmers on the internet and fuel unprecedented levels of innovation in the browser market. While Firefox remains a strong engineering-led organization, we've grown our UX and product teams significantly in the last several years. In 2017, we came together to focus on a major desktop browser update for our Firefox 57 release, which we named Quantum. It included numerous improvements to the Gecko browser engine and a large visual refresh of the browser, all with the goal of making sure Firefox felt super fast. Our user research team recognized this as an opportunity to integrate these two efforts by actually measuring our user perceived performance for the very first time. We decided to conduct a benchmarking study using unbranded builds of both Chrome and Firefox. There are many factors that influence browser usage, but performance is one of the core motivators. This is an example of one of the advertisements we used when Quantum eventually launched. In this ad, Reggie Watts is interpreting the contrast between a slow and a fast browsing experience. So what do we actually mean when we're talking about performance? Perceived performance refers to how quickly software appears to perform a given task and is an important element of a user's overall experience. It's important to note that perception of time should not be assumed to be an accurate measurement of time. The actual duration reflects objective time, and perceived duration reflects subjective psychological time, which is susceptible to varying degrees of distortion. However, perceived duration should not be regarded as any less important for user-facing products. Another consideration with perceived time is both active and passive time. Active time is characterized by an engaged mental activity for the user, and passive time is characterized by a lack of engagement. These are two modes that users typically move between when they're engaging with a product or service. So one real-world example of active versus passive time is choosing to drive the back roads instead of waiting in heavy highway traffic. Even if they take the same amount of time, it'll feel faster to be moving. Research shows that on average, people engaged in a passive wait overestimate their waiting time by about 36%. Therefore, it's essential for designers and developers to find ways to limit the amount of time users are spending in this passive phase. Another example, years ago in Houston, airline customers were complaining about baggage claim wait times. In response, the airport doubled the baggage staff, but the complaints kept coming. After some research, they found that it was actually the idle time waiting for the baggage that was the true issue. So in response, they actually just moved the baggage claim further down the hall so that even though it took the same amount of time for the bags to appear on the carousel, it just felt so much shorter to be walking for a part of that wait versus standing idly. Perceived performance is largely determined by four main factors: duration, responsiveness, fluency, and tolerance. Duration is the actual duration that a process takes. This is the element that's often referred to as performance in technical discussions. So different magnitudes of duration require different treatments to achieve optimal perceived performance. And responsiveness is the perceived time it takes the system to respond to user input. For example, let that load. An empty dialogue appearing immediately after a click and then taking a second to populate with content feels faster than the same dialogue appearing with a second delay but fully populated. Fluency is the perceived smoothness of a process. It could also be described as a measure for how hard the machine appears to be working. So for example, a stuttering progress indicator gives the impression of lower performance, regardless of the actual duration of the process. Tolerance is a measure of how long the user expects a process to take and at what point they will abandon or cancel the process. For example, the tolerated duration for loading a web page is going to be much different than for saving a bookmark. So next, we'll be taking you through how to actually set up a perceived performance study using the quantum Firefox research that I mentioned at the beginning of this talk, and some recent work on an experimental mobile browser as case studies. So I'm going to turn over to Heather now to introduce the mobile research and to talk about our desktop and mobile perceived performance research.
Thanks, Gemma. Great. So last year, the Firefox team started working on a new mobile browser powered by Firefox's new rendering engine, GeckoView. We knew how critical great performance was for the mobile experience, especially coming off of what we'd just sort of launched with desktop. So we wanted to understand and prioritize performance efforts that would have the most impact on users and identify opportunities for the user experience to feel fast. I'm going to walk through the high-level steps of running a perceived performance study, as well as some of the findings and the impact this research has had for us. Okay. So for both desktop and mobile, we needed to identify our stakeholders. In these types of projects, stakeholders might extend beyond the performance team and beyond the engineering team. So for example, for us, our stakeholders were product managers, engineering managers, engineers, and designers, and even content strategy. So, oh, and sorry, one thing I also wanted to mention is it went across product teams too. So yeah, it spanned like a few different areas that we were looking at. So once the stakeholders had been identified, work with them to determine the goals of the perceived performance study. And this goes back to the intent that you've heard a few times today, so really understanding like what is the purpose of what we're going to do. Because this will inform a lot of things, but to start, it will inform what the research program looks like. So for example, with our quantum desktop study, we had two goals. The first was to identify the greatest areas of improvement for perceived performance and user preference. And the second was to evaluate what perceived performance improvements had been made to this new version of Firefox. So this meant that we needed to benchmark the product against itself over time, but we also needed to do a comparative study against our competitor Chrome and benchmark that over time as well. So once the research goals and approach are identified, you can figure out when the study should be scheduled. And you can do this by understanding two things up front. The first is when the builds will be available for you to evaluate. And the second is when the findings from the research will have impact. So it's important to make sure that the team will have time to act on the results. Knowing the release schedule and the product roadmap can help determine when the findings from the research will be actionable by the team. Once it was time for us to run the study, we ran a kickoff meeting with our stakeholders. The project kickoff is a critical step in a process, and it should cover what the purpose of the study is, as well as what questions or hypotheses your stakeholders have. So this is a really good time to have team alignment. This will help inform what your research questions are, which will then inform what participants to recruit, so what's your criteria for your participants, and what tasks and questions to include in your study. You'll also want to find out during a kickoff what the team already knows, and this could come from many places. It might be previous performance tests or metrics that the company has, or recurring themes from product reviews or customer support. You should also find out if there's any upcoming decisions, changes, or milestones that might impact the decisions impact the product. And identify what devices and builds are needed for the study. So for example, we wanted to run the study with unbranded builds of Firefox and Chrome, so we worked with the engineering teams to prepare those builds. Both Chromium and Firefox are open source projects, so the engineers were able to take the code and remove all of the branding from it and create the browser builds that we then installed on the test devices. So you can see like this is on one of the test devices, and those are like two versions of like unbranded Firefox and unbranded Chrome. So by identifying the questions the team had and looking at what we already knew, we identified a set of tasks to evaluate. And these included browser-specific tasks, like the speed of opening the browser, and site-specific tasks, like filling out a web form. To select which websites to include in our site-specific tasks, we looked at secondary research, and we also worked with our stakeholders. During our study planning, we also identified the controls we needed to put in place. These are the parts of the study that you either need to keep consistent or vary in order to have valid results. For our studies, we were thinking about which devices to select. So for example, in our mobile studies, we chose a high-end, high-bandwidth mobile phone, as well as a low-end, low-bandwidth mobile phone. This was really helpful during analysis because we were able to compare the data collected by those two different groups and see some interesting differences. We also alternated the order of both the browsers and the tasks that participants were given, which helped us mitigate an order bias. And finally, we used the unbranded builds for our study to mitigate a brand effect with Chrome or Firefox. At this point, we were able to define criteria for who we needed to run the study with. So we wanted to have two groups of participants, those that used Chrome as their primary browser, and those that used Firefox as their primary browser. When we were planning our desktop study, we also wanted to have a group of participants living in a rural location and a group of participants living in an urban location to think about high and low bandwidth. We also knew that we needed to be able to see statistical significance in our data, so that helped us determine how many participants to include in our study. So for example, with our desktop research, because we wanted to have statistical significance between urban and rural locations, we had 20 participants for each. Once the questions and tasks were defined, we could create our guide for running the sessions. We ran our studies in a lab, which allowed us to control for the test environment, and each session was conducted one-on-one with our participant and ran about 45 minutes. During that time, we interviewed them about their current attitudes and experiences with the browser, and then had them complete the set of tasks and rate the responsiveness on a 7-point Likert scale. Each participant went through the set of tasks on the two different browsers that we were comparing. We then wrapped up with their preference and overall perception of speed and a discussion. And once we were done with the sessions, we were ready for analysis. So during analysis, we focused on responsiveness rating averages, as well as the percentage of people that preferred one of the browsers over another. We looked at whether the responsiveness rating average between the two browsers they used was significant overall, but also we looked by task, by browser order, bandwidth, and whether they were primarily a Firefox user or primarily a Chrome user. We also looked at whether the percentage of people that preferred one browser over the other was significant along those same variables. We used significance testing to assess comparative outcomes to determine whether the difference Oh. Okay. Okay. All right. It's okay. So yeah, we used significance testing to assess the comparative outcome to determine whether the difference between them was caused by something other than random chance. So our team used a 90% confidence level to test for statistical significance, which meant that we could be 90% sure that the difference in percentage was not due to random chance. So I want to share with you a few of the things that we were able to learn from the research. On mobile, in our initial benchmarking of Firefox against Chrome on Android, we found Chrome outperformed Firefox in most categories in statistically significant ways. The average responsiveness rating was higher on Chrome, and we found that the majority of tasks where Chrome had felt more responsive involved page loads or interactions done while the page was still loading. When comparing our old rendering engine WebView against our new one, GeckoView, we found that the old one outperformed GeckoView in a number of statistically significant ways as well. We also found that participants didn't perceive page load accurately. So as long as the structure, the main content, and the key actions were loaded, participants considered the page loaded, even if a long tail of things filled in after that. In other words, if they weren't blocked from their intended goal, they didn't consider that to be an issue. Interestingly, when we looked at the results on both mobile studies, we saw a low bandwidth effect. So what we noticed is like when we separated the data between the low-end low bandwidth device and the high-end high bandwidth device, there was statistical significance between the responsiveness ratings on the low bandwidth and statistical significance for the preference over one browser over the other on the low bandwidth, but that disappeared when we were looking at the high bandwidth. On desktop, in our initial benchmark, Chrome outperformed Firefox on the majority of site-specific and browser-specific tasks and was the preferred browser by most participants. A few big things that we worked with the engineers to address were to improve the speed of opening the browser, improve animations to better represent loading and page load completion, prioritize the foreground tabs over background tabs, and prioritize content that people care about. So for example, if we're loading a page with an article, loading the article first while delaying scripts with ads and tracking domains. When we followed up 3 months later with phase 2 to measure the progress, we found that Firefox had statistically significantly improved responsiveness, including in the majority of site-specific tasks, which are circled. We also found users preferred the new tab experience on Firefox because of its significant speed advantage over Chrome, as well as the UI updates that had been made. And interestingly, we also found that the Close tab dialog box in Firefox received many favorable comments, despite lengthening the time to close the browser. In fact, we observed many times when feelings of like user-friendliness or good user experience contributed to the participants' preference rating. So we've learned a ton from running these studies and starting to build out this program in Firefox. And it's been a really nice complementary addition to the performance tests that are already happening at the company. It's been really useful to this sounds like so basic, but it's been really useful to actually be able to watch our users like do these tasks and talk about them and be able to share that back with engineering. Following the results of the studies, the team found a number of performance-related bugs to improve perceived performance on our product, and it's been helpful to run these studies over time to measure the improvements that have been made and where we need to continue focusing. One of the biggest benefits from understanding the perceived performance has been the ability to identify where we can make the biggest impact for our users' experience. Our engineering team knew some of the major areas where performance needed to be improved, and much of what we found out was complementary, but being able to point to the biggest perceptible issues helped us prioritize what will give our users the most impactful improvements in their experience.
Okay, so running a perceived performance benchmarking study before a major release, like Firefox Quantum, is an important way to assess how users experience design and engineering updates. And once the initial research design has been created, you should consider maximizing this investment by running perceived performance benchmarking studies on a regular basis. This might be at every major release or on a different cadence that works best for your organization. But as long as you can carve out a little bit of time and the budget for recruitment, a lot of the heavy lifting will have already been done because the study will be almost identical. So how does Firefox think about perceived performance today? It's been about 1.5 years since we ran our first perceived performance study on Quantum, and we've now run perceived performance studies on all of our major browsing products. Perceived performance has become widely used terminology for defining product goals and for measuring success. And we also recently hired a dedicated perceived performance product manager. And we also have user research staff to a variety of perceived performance projects. In the future, we'd like to hire a dedicated perceived performance user researcher and extend our perceived performance research to locations outside of North America. And finally, we would really like to establish a regular perceived performance research cadence, and ideally one that's not only tied to major releases. So if you would like to learn more about researching perceived performance, these are a few resources we'd recommend to start. The first two are short articles that provide a good basis for learning. The first is Shorter Wait Times, the effects of various loading screens on perceived performance, and Subjective versus Objective Time Measures, a note on the perception of time in consumer behavior. And the last three are books, Designing with the Mind in Mind, Thinking Fast and Slow, which is pretty popular. I'm sure most people have heard of that one. And then Designing and Engineering Time, The Psychology of Time Perception in Software. We'd also recommend checking out our Firefox Photon design system, which you can find at design.firefox.com. There's a really great short section on designing for performance, as well as a number of other useful resources. And those short video clips I shared earlier, you can also find those at this website, which are great to demonstrate some of the different ways that people are thinking about perceived performance. So thank you so much for listening to us today. You can access a copy of these slides at the bit.ly URL at the top. And if you aren't already, we hope that you will consider introducing user perceived performance research to your organizations. Please find us tonight at the after party, and we would love to keep talking about this. Thank you.